Hi friends, in this video I am giving you brief idea about how to arrange the set of numbers into descending order. So in the previous video I explained how to arrange the set of numbers into ascending order. Let us see here how to arrange the given set of numbers into descending order. Okay. See the problem, assembly language programming of 8086. So in that our aim is write an assembly language program to arrange the given set of 8-bit numbers into descending order. Okay, so here also we are taking an array of 8-bit numbers, right, and arranging that particular array of 8-bit numbers into descending order. Okay, so for this particular problem I am taking count is 5. So and what are the numbers? 30, 10, 50, 20 and 70H are the numbers I am selecting, and I need to arrange these numbers into descending order. Okay, here also what is my count? 5. So for selecting this particular count I need one location. So for this particular case I am selecting 2000H is the memory location for selecting count value. Now later I am selecting 5 locations, starts from 3000 okay to 3004. These five locations contains our example. So what is our bits? See, 30H is the first byte, 10H is the second number, like that 70H is the fifth byte. So 3000H to 3004 locations contains our number, starts from 30H to 70H. Okay, 5 bytes are available in the memory locations 3000 to 3004, and our count is 5. And here we are selecting count in which location? 2000 location. Like previous video I explained ascending, same model here also, right. So here for descending order representation there is one important instruction called as JGE. What is the name of JGE? Jump greater than or equal. So this instruction will check first byte with next byte, okay, with the condition jump greater than or equal. Let us see. Okay, this instruction is useful for writing the program. Anyway, in the programming part I will explain. Let us see here first iteration. So actually my count is 5. Okay, so here also how many iterations are required? If count is 5, 4 iterations are required, and the maximum number of comparisons should be 4. So for any sorting problem, if n is the count, so then n minus 1 iterations are required and n minus 1 comparisons are required maximum. Okay, let us see first iteration. So I am taking same number 30H, 10H, 50H, 20H and 70H initially. So in which way I am comparing? First I am comparing first byte with the second byte. So what is my condition? Whenever my first number is greater than or equal to second number, then no need of exchanging, keep bytes as it is. Unfortunately, whenever my first number is less than second number, then exchange these two bytes. Okay, this is the way of arranging the numbers in descending order. So now in this particular problem what happens? My first byte is greater than second byte, so no need of exchanging, keep first byte as it is, second byte as it is, and remaining 3 bytes also we are indicating same value 50, 20 and 70, no exchange. This is after first comparison. Coming to second comparison, in second comparison what happens? We are comparing second byte with third byte. So in that also whenever second byte is greater than or equal to third byte, no need of exchanging. Whenever second byte is less than third byte, exchange. See here in this example, second byte is less than third byte. Then what happens here for descending arrangement? We should exchange second byte with third byte. So after exchanging what happens? 50 comes to second byte position, 10 comes to third byte position. Okay, remaining 2 bytes write as it is 20, 70. So coming to third comparison, in that I am comparing third byte with fourth byte. So whenever my third byte is greater than or equal to fourth byte, no need of exchanging. Whenever third byte is less than fourth byte, exchange. So in this example, third byte is less than fourth byte. So you should exchange third byte with fourth byte. So after exchanging, so now fourth byte comes into third byte position and third byte comes to fourth byte position. Keep fifth byte as it is. Okay, this is after third comparison. Coming to fourth comparison, now here I am comparing fourth byte with fifth byte. So whenever fourth byte is greater than or equal to fifth byte, no need of exchanging. Whenever fourth byte is less than fifth byte, exchange. So in this example, what happens? My fourth byte is 10. That is less than fifth byte. So then what happens? I need to exchange. After exchanging, what happens? 70 comes to fourth byte position, 10 comes to fifth byte position. So at the end of first iteration, we get the smallest number, okay, as the last byte. So now it is freezed. Smallest number we achieved. Then what is the next step? Go to next iteration, second iteration. So for first iteration we are comparing 4 times, 4 comparisons are required. Okay, and coming to the second iteration, okay, at the end of first iteration we freezed the smallest number among the given array. Next, what is the next case? Coming to iteration 2. In iteration 2 we are taking this arrangement into account. Here also coming to first comparison. In first comparison, first byte is compared with the second byte. Okay, so in same manner in which I explained in iteration 1, same way for iteration 2 also. See here, so in this example what happens, my first byte is less than second byte. So I need to exchange these two. So after exchanging, what happens, 50 comes to first byte position, 30 comes to second byte position. So remaining 3 bytes as it is, 20, 70 and 10. So coming to second comparison. In second comparison, second byte is compared with third. Here also my second byte is greater than third byte. So no need of exchange. Keep second byte as it is, third byte as it is. Okay, then remaining 2 bytes write as it is, 70 and 10. So coming to third comparison. In third comparison, I am comparing third byte with fourth byte. So in this problem, what happens, my third byte is here less than fourth byte. So I need to exchange. After exchanging, what happens, 70 comes to third byte position, 20 comes to fourth byte position. Then write 10 as it is. So already we achieved 10. Now second smallest number we got from second iteration. Here number of comparisons are 3 only. So first iteration 4 comparisons, whereas second iteration 3 comparisons only. Okay. Now at the end of second iteration we get 2 smallest numbers. Okay. Now coming to third iteration. So take this arrangement, same arrangement we are taking here. Okay. Here also first comparison. In first comparison, what happens? First byte is compared with the second. In this example, first byte is less than greater than second byte. So no need of exchange. Keep as it is. 50, 30. 50 here 30. So 30. Next similarly, this side 70, 20 and 10. Now this is after first comparison. Coming to second comparison, here I am comparing second byte with third byte. So in this example, what happens? My second byte is less than third byte. So I need to exchange second with third. So that 70 comes to second byte position, 30 comes to third byte position. Keep 20 and 10 as it is. Okay, this is after comparing second comparison. After getting second comparison, what happens? We get third least number. So 30 is achieved. So in third iteration we get third least number. Okay, so now 3 numbers are freezed. So here how many comparisons in third iteration? Only 2. Coming to fourth iteration, so take same numbers into fourth iteration, 50, 70, 30, 20 and 10. So what is first step? Compare 50 with 70, first byte with second byte. So here whenever first byte is greater than or equal to second byte, no need of exchanging. But here first byte is less than second byte. Then what happens? I need to exchange. Then 50 comes to second byte, 70 comes to first byte. Okay. Then at the end of first comparison itself, we get the fourth least number. Then this one becomes fifth least number. Okay. So for fourth iteration, only one comparison is enough. Like that. What is our observation? So if n is the count, then n minus 1 iterations are required, and the number of iterations are decreasing from first iteration to fourth iteration, and maximum number of iterations should be n minus 1 only, and maximum number of comparisons should be n minus 1 only, and iteration to iteration comparisons will decrease. So at the end, where we need to print the results? 3000 to 3004. So 3000 contains 70, 3001 contains 50, like that. The 3004 location contains 10. Let us verify these values. So how to write the program? So what are the numbers I am taking? So 30, 10, 50, 20 and 70. Later we will verify in the experimentation part. So then minimize this one. What is first step? Open DOSBox. Okay, so programming is more or less same as ascending order programming, only few instructions are changed. Okay, then Alt Enter to get a full screen. So let us see what the command mount. MOUNT, mount space D space D colon slash D colon space 8086, then edit. We get like this. So here first step is select code segment, then assume directive CS colon code. Above instruction will assign 16-bit logical into 20-bit physical. So for every program it is essential. Then start of the program, start of the assembly program. Okay, then writing any program, first we should clear which general purpose registers are used in our program. So here I need AX, that's why I am clearing AX. X or X comma AX, it will clear AX value. Then move BL comma AL. So my BL is also cleared. Then move CL comma AL. My CL is also cleared. So from this which are cleared, AL value, AH value, BL value and CL value are cleared. Then what is first point? I need to select count in the location 2000. For that I am writing move SI comma 2000H. At the end of this instruction, what happens? SI will take 2000H value. Then I am writing move BL comma box of SI. So in this instruction, what happens? My BL takes data from 2000 location through SI register. So it is nothing but initially my N, nothing but count array information is given in BL. Then what is the next step? Decrement BL. Why I am writing decrement BL? If N is the count, so the number of iterations should be N minus 1 only. For that I am decrementing BL. Then what is the next step? Move CL comma BL. So in this instruction, what happens? My BL is N minus 1. CL is also equal to N minus 1. So CL is for comparison purpose. BL is for iteration purpose. For that I am duplicately moving BL into CL. So both are now in our example. For example, 2000 location I am selecting 5. Then my CL and BL values become 4 after decrementing. Then what is the next step? I need to select the 5 numbers starts from 3000. For that move SI comma 3000H. What is first step? Right? Move AL comma box of SI. So in this case, what happens? My AL takes data from 3000 location indirectly. So indirectly AL takes first byte of our problem. Okay, that byte is compared with the second byte. For that compare CMP AL comma box of SI plus 1. So in this instruction, what happens? My AL is compared with the second byte value that is stored in 3001 location. After comparison, we are checking which instruction we are checking. JGE jump greater than or equal. So what is the meaning? Whenever my first number is greater than or equal to second number, then no need of exchanging for descending order. Then it will go L1. Unfortunately, first number is less than second number. Then what happens? It comes to next line. So in that I am writing exchange which values AL comma box of SI plus 1. So after exchanging, now first byte is moved to second byte position and second byte is moved to first byte position. So move this AL value into memory location again, because where we need to see the results in memory location. For that move box of SI comma AL. Okay, like this is the point we are observing. If that condition is failed, if that condition is succeeding, means my first number is greater than or equal to second number, then it will comes to L1 position. In that L1 I am writing increment SI. Then what is my SI? Previously 3000, now it becomes 3001. Then loop L1. So what is the meaning of loop L1 instruction? Initially my count is N minus 1. So loop L1 instruction will decrement the value of CL by 1 and checking whether CL is 0, 0 or not. For example, CL is in previous point, CL is 4. Now it is decrementing by 1. What is my CL 3? Is it 0, 0? No. Then it will go to L2, where I am writing L2 here. So then in that case, what happens? My AL takes data from 3001 and the data is compared with the 3002 location data. After comparison, again we are checking. Okay, like that this loop repeats for how many times? 4 times, because my CL is N minus 1. That is 4 in our case. So 4 times this loop repeats. Okay, like that we, at the end of this loop L2, we get one iteration, the first iteration. Like that how many iterations I need to perform? N minus 1 iterations total. For that I am decrementing BL. Then initially what is BL here? 4. After decrementing now it is 3. It indicates we have 3 more iterations. Then we are checking whether all iterations are completed or not. For that jump no 0, L3 to L3. So remember here for first iteration only we have N minus 1 comparisons. For second iteration we have N minus 2 comparisons. So first iteration we have 4 comparisons. Second iteration 3 comparisons. Like that iterations also decreasing. Similarly comparisons are also decreasing slowly. For that I am moving L3 here. Then my CL for second case what happens? My CL is equal to now 3. BL equal to 3. Nothing but how many comparisons we are performing? 3 comparisons. Like that these two instructions for making increasing iterations. Nothing but iteration 1 to last iteration. Then at the end I am writing int 3. Then code ends. Then end start ending of the program. Then file save. So what is the file name? For example, descending des1.asm. Descending 1.asm. Then file exit. MASM des1.asm 4 times enter 1 2 3 4, then link des1.obj 4 times enter 1 2 3 4, then debug debug des1.obj exe debug space file name dot exe, one time enter, then g equal to 4 zeros. Is over. Then where I need to give count 2000, for that e space 2000. Okay, that I am giving count is 5, nothing but my n is equal to 5. So where I need to give number starts from 3000, for that e space 3000. So what are the numbers I am giving? So in my problem 30, I think 10, then 50, then 20 and 70. Like that I am giving 5 bytes. Then run again. G equal to 4 zeros. So where I need to see the results start from 3000. So what is the command for seeing results? D space 3000 comma 3004, same locations. Now making results into descending order. Let us see 70, 50, 30, 20, 10. Like that we are arranging set of numbers into descending order or array of numbers into descending order easily. So in order to exit, make it like a quit, then exit.